if g is differentiable, so it means if you can do the derivative at x and f is differentiable at g of x, then the composite function f equals f open dot g is defined by f of g of x, right? It's differentiable at x, and f prime, remember what do we do when it's the chain rule? You take the derivative of the outside, rewrite the inside composition function, right? And then multiply by the derivative of the inside, right? And if there's more than one inside, you'll keep chaining. You'll do the derivative of the outside, then the derivative of the inside, the derivative of the inside of that, the derivative of the inside of that. You might keep going if there's more composed functions inside each other. So, we're going to look at example 1. We've looked at these in somewhat of detail already. Why is this one going to be a chain rule? Because there's two functions. There's a function embedded in a square root. Right. So what we do whenever we want to find the derivative, though, is we rewrite it to a rational exponent, which is why we learned rational exponents in grade 10. Remember, for this moment and for the moment in grade. Don't move. Don't buckle to them and their lateness. All right. So we have x squared plus 1 to the half. Try it out. See how you do. So, chain rule states that if I have a function composed inside another function, I have to do the outside, then derivative of the inside, and chain link after that. So, quiet please. So I do the outside first. So I do power rule. Half drops in front. Rewrite the g of x. So rewrite the inside. X squared plus 1. And then drop it by 1. So now it's to negative a half. Correct? So I just did the outside. So I literally took the exponent, dropped it in front, and reduced the exponent by 1. Rewriting that inside to be exactly what it was. Yes? And if you look at the formula, it says g of x just stays g of x, so that's that inside stuff, just stays how it is. Then I have to make sure that when I say I'm done, that I have done the derivative of everything. So what have I not done the derivative of yet? The inside. So it gets me another chain behind it. That's why it's called chain rule. Chain, 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 chain. So the derivative of the inside now is what? What's the derivative of x squared plus 1? 2x. So this to the negative a half will drop to the denominator. The 2 is on the denominator, and the 2x stays in the numerator. So I'm going to get that 2 in the denominator becomes the half. The x squared plus 1 goes to a positive a half. And the 2x stays in the numerator because it's positive. Is there anything else I can do? What?
Yes. You get rid of the 2's.
You take the x squared plus 1 and put it under square root. You can cancel off the 2's because they're both monomials. Okay? Because 2 and x are multiplied and the 2 in the bottom is by itself, so they can cancel off. So I can write it in fractional exponent, or they might write it like this. Done. Okay. Example 2. I have an A and a B sitting beside, because I want you guys to see that they're very different questions. The first one is the same as yesterday. Sine x squared. The x squared is in the bracket. So this isn't a chain rule. This is just sine, cos, tan, secant, right? Not a chain rule. So sine x squared, I will do the derivative of sine. You kind of chain, but it's not the same way as a chain. So I'll do my derivative of my sine. What's the derivative of sine? Cos. And I rewrite the bracket. So technically it's a chain rule, but you still do the trig first. So the derivative of sine is cos x squared. And what have I not done yet? The derivative of x squared, which gets me a chain behind it. So yesterday it was always x's. Remember I told you everything yesterday was just x's, x's, x's. So you stopped because the derivative of x is 1, so you didn't get a chain behind. But today we can do chains. So we can chain behind. This is correct. They will never write it like that, though. They'll bring the 2 to the front as a coefficient. Now, what you guys have to remember, is everyone paying attention? Because everyone will get this wrong. Do you see this? That is one entity. Do you see that? That's like saying cos of 90, or cos of pi over 2, or cos of 180, or cos of whatever, correct? Okay. Is that what you're going to put your hand up for? Yeah. There's a little teeny tiny x in there. So this 2x cannot join the x squared. Because that would be like, this is 90 and then this is 2x. Can that join in and just jump in with the 90 that's attached to a cos? No. Whatever's attached to a cos has to sit there. Yep. The derivative of x squared. I'll rewrite it because it looks terrible because I didn't write 2x in the first place. All right. B. Everyone has to pay attention. This one is sine squared x. And remember I told you, how would we have to type them into our calculator if we had sine squared x? Do you remember?
Sine, bracket, sine x, bracket, squared.
Yeah. Not wrong. Bracket sine, bracket x, bracket, bracket squared. So he's saying that this is the same as writing having two signs. Right? Having a sine times a sine. Yes? So you can't type it in as sine squared in your calculator no matter how much you want to last semester, because the moment you press sine, an open bracket happens. You can't get a little square in before the open bracket, yes? So last year your teacher would have told you last semester, your teacher would have told you that you have to go sine x all squared. Which is what you just said. Okay. So y equals sine x squared. It's funny if you just whatted your own answer. You went, what? And I just said exactly what you said.
No, so you said our teacher.
Some people's children. Actually, I love the older sibling of that person. And, yeah, your sister's awesome. I like you too, Kyle. She's so not nice. All right. Joking. Haha, she's great. So, why would I rewrite it like this? Why would I rewrite it like that? Because now you have to do chain rule, yes? So y prime is going to be, to do the outside, then the inside. So we go 2. Rewrite the inside. Please don't do the derivative of the inside. That's not chain rule. That's what people doing all the time. They'll go 2 cos x to the 1. That's not what we want. We do 2, rewrite it to the 1, and now we chain behind the inside. What's the derivative of sine x? Cos x. So our answer is just 2 sine x cos x, which is actually sine 2x off the formula sheet from last year, if you were curious. Okay, I'm giving you another little caveat. I want you guys to try this one. Cos cubed 3x. How do you have to write it first?
Bracket, close, bracket, dx, bracket.
I love how you explain all the brackets. Yeah, we have to just go cos 3x cubed. But yes, all your brackets were correct. So the first thing we have to do is just rewrite it as cos 3x all cubed. So try it out. Give me the derivative. So y prime, we start from the outside in, so we're going to get 3, rewrite our inside function, to the what? To the 2. Then I follow behind with the derivative of cos. What's the derivative of cos? Negative sine, because all c's will be negative. Negative sine 3x. Yes? Then what? Yeah. The derivative of 3x, which is 3. At the end, you have to do the derivative of everything working from outside in. So we have not done the derivative of 3x, which will get us a 3. Now I need you to pay attention. Most people can get to here, and then they can't get it to match multiple choice, because they don't know how to put it back together. So let's look here. 3 is a coefficient. This is a negative 1. Yes? And this is a 3. This 3x is attached to the cos, that 3x is attached to the sine. I can't do anything with those, right? They're part of the sine and the cos. They are one entity. Okay? But I can move the 3, the negative 1, and the 3 to the front. So I get negative 9. Sine 3x, if I so choose, to go first. It can go second. It doesn't matter. But the cos to the 3x squared is correct. It's not how they'll write it, though. We have to change it to that in order to do the derivative. but then we'll move it back to what it was. Just the same thing as like when we take our square root, we write it as to a half or a cube root. We write it to a third. But then at the end, we change it back to squares or cube roots, right? So the catch here is this cos 3x squared is what we use to get the derivative, but we have to remember to put it back in between when we're done. So the last one we didn't have to do that because it was sine x to the 1. I could have put a 1 back in between, but does that do anything? No, so I didn't really have to. So that's why I gave you 1 to the power of 3. Anything to the power of more than 2, you're going to have to remember to bring it back in. So I'm going to get cos squared 3x. Okay? Yeah?
Can you do the original left hand equation? The 3 at the very end.
Sorry?
The 3 at the very end of the left hand equation.
3 times negative 1 times 3 is negative 9.
No, the last 3.
This one from the derivative of the 3x. So we did the derivative of the outside, brought the 3 dropped in front, and we did derivative of cos, which is negative sine 3x. Then we have to do the derivative of 3x, which is 3. Yeah, outside in. Because that 3x is composed in the function sine x, right? So you break yourself out into new brackets in every single composition. All right. I want you guys to try A and B. B, what am I going to have to do? Change that to 1/3, right? Cube root is to 1/3. How do I move it to the top so I can just do power roll? How do you move that from to 1/3 to the top? Negative 1/3. You just have to raise it all to the power of negative 1/3, then it's at the top. Just do your good old chain roll. Try A and B. The first one, what are we going to do first? Shh. So remember, let's think about the composition. If we understand why we do stuff, we do better, right? If we just try and memorize skills, things go really crappy. So the reason why we actually do chain rules is we're working from the outside function in. So technically, if this was f of g of x, g of x would be x cubed minus 1. That's easy, right? And f would be x to the 100, right? F would be x to the 100, and then g of x would be x cubed minus 1. So the more composition of functions you have, the more chains you will get because of that. Okay? If we go back to this one back here that I just made up, we have a first function. Say in this one actually is 3. It's f of g of h of x. That's what this one technically is. F would be x cubed. Yes? G would be cos x. H of x would be 3x. Right? So every single time you get a function composed inside another function, you get chains. Every time. So this one has 2 functions composed. I'll get 2 chains. So y prime equals x to the 100, which would end up being 100 x to the 99. X just happens to be a function that is not just x. So I get 100 x cubed minus 1 to the 99. So now all I did was actually the derivative of the outside. Then I do the derivative of g of x now, which would be 3x squared. Now because this is a monomial and this is a monomial, they'll actually put them together often. And they will rewrite it as 300x squared, x cubed minus 1 to the 99. Yes? Okay. If we look at B, I told you let's rewrite that one because in the form it is currently, it's not that fun. But I can rewrite this as x squared plus x plus 1 to the 3rd, and then I can bring it up, and it will be x squared plus x plus 1 to the negative 1/3. Because if I move anything from the denominator to the numerator, it just changes, your exponent changes signs, right? So if I have that to the positive 1/3 on the denominator, if I move it up, it goes to the negative 1/3. And what would be my denominator now? 1. Just like the number 7 has a denominator, it's 1. Okay, do I need to write it? No. So now I can do chain rule. My f of this one would be x to the negative 1/3, and then my g of x, which is composed inside, would be x squared plus x plus 1. Do you see what I'm saying? This would be the outside function, this would be what's composed inside of it. So f prime of x is going to be negative 1/3. Rewrite the inside. When I subtract 1 from 3/3, what do I get? Or, sorry, 1 from negative 1/3, what do I get? Negative. Don't all answer at once. What's negative 1/3 minus 1?
2/3.
Negative 4/3. And then I have to follow behind by the derivative of the inside. So I get 2x plus 1. Okay, let's do this. My denominator of this, thanks, blue marker, for not getting what I need. The denominator of both of those is 1, yes? You don't need to write that, I'm just doing this to prove a point as to why some things stay on the top, some things stay in the bottom. So, my negative 1 is going to stay in the top. Some people are like, well, can't I just move it to the bottom and make it positive? No, moving from denominator to numerator and numerator to denominator changes the sign of an exponent, not the sign of just a number. So, the negative 1 stays at the top, the 2x plus 1 stays on the top, and this is negative. This is negative, so I can take this and drop it to the denominator and make it positive, yes? And the 3 is already in the denominator, so it just sits down here. And now I have x squared plus x plus 1 to the 4/3. Which if they want to, depending on who you get as a prof or what your multiple choice answer is, the denominator could be 3 cube root of x squared plus x plus 1 all to the 4. But I'm fine with it staying like this. Okay, C, don't write large. Okay, don't write in large font for C. C is one that people will find easy if they remember how to do it. What people often try and do is they try and distribute the 9 in first and then do quotient rule with the 9, which makes it actually harder. It's not the best way to go about this. So I'm going to star this one. Just because it's often forgotten about. One for extra measure. Just really prove a point. Want lots of stars? Let it, just kidding. Oh, it didn't work. Let it go. We have to do chain rule first. We agree? So we are going to get, and we're not going to write massive, g prime of x. We're not going to distribute the 9 in. We're going to do chain rule, which means our original function is x to the 9, yes? And our composed function is this ugly rational expression in the middle, okay? So the 9 is going to drop in front. If you want to, if you so much like it, most people like to write it as a 9/1 for later reference. Then I get this, x minus 2 over 2x plus 1 to the what? To the 8. Cool. I did the outside. What do I now have to do the derivative of? The inside. And the inside is a what rule? Quotient rule. So we're going to follow behind with a quotient rule. Remember, we goof. We do g f prime minus f g prime. We goof. So g is 2x plus 1. This is my g. This is my f. F prime is what? 1. And g prime is what? 2. Okay, so we get g times f prime is not that. G times f prime plus f times g prime all over just g squared. So nothing crazy, correct? What did I tell you to do in the numerator? I told you to look. Is there anything I can GCF out? There's not. Then I look behind. Yeah.
Is there a subtraction sign in between? Or is that for something else?
I have no idea what you're talking about. There's a subtraction sign right now. Totally a subtraction sign. Always has been a subtraction sign. Never was it a plus sign. Are you one of those things like they have for like Men in Black, you know, like where they have the little button and they press it and everyone forgets everything that just happened. But like, it only can be like, it like just knocks it back like 5 seconds. Like, I don't want you to forget the whole lesson that stuff, which is like, because I wouldn't want you to miss my remembering my Let It Go rendition. But you know, this, it's like 5 minutes. And then like, oh, I got minus sign. It's good to know what's that. All right. So, the numerator is polynomials. There's nothing I can take out of them. Yes? So what did I tell you to do then if it's just all polynomials? Yes, distribute and then collect like terms. AKA multiply and then add, which is true. Kind of subtract, but we're good. So, we have g prime of x. Remember, I Men in Black. If you guys don't remember, that was a plus sign ever. It was always a minus sign. It's perfectly fine. X minus 2 over 2x plus 1 to the 8. Then we distribute. So we get 2x plus 1, and then we distribute. So it's be 2x, but we have to remember to distribute the minus sign through. So it'll be negative 2x, and then this will be negative 4, and when I distribute the minus sign through, I get a 4. All over 2x plus 1 squared. Then those cancel. And most people get to this point. 9 over 1, x minus 2 over 2x plus 1 to the 8. And then 1 plus 4 is 5 over 2x plus 1, and then they say I'm done. There's one extra step that you'll probably forget to do. If you look at the denominator of this first one, what's down here? 2x plus 1. What's this one have? 2x plus 1. So my last step that everyone sometimes forgets to do is you can now distribute the 8 through. This would be a good time to put the 8 through. Not at the very beginning, when it was a 9. Put the 8 through. So I'm going to get 9 over 1, x minus 2 to the 8 over 2x plus 1 to the 8 times 5 over 2x plus 1 to the 2. Now if you look at the denominator right now has 2 bases that are the same, right? With 2 exponents. What do I do when the bases are the same and I'm multiplying and I have 2 exponents? Add them. So currently I have, bear with me, 2x plus 1, 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 and then 2x plus 1, 2x plus 1. So how many 2x plus 1s do I have? 10. Right? That's why you add the exponents, because if I have this many, then I have this many more, and that's just 10. Right? So my answer is going to be 45, because I can put the 9 and the 5 together. X minus 2 to the 8, all over 2x plus 1 to the 10. Okay? Perfecto. Then flip over. Right there. You want to distribute the 10 in? No. No, you have 10 of them. You'd have to FOIL 10, like 5 times, and then combine, and then it would be awful. And then don't do that. Okay. Oh, Elsa. All right. What's here? What is the first rule I have to do? I see 2 things multiplied, so what do I have to do? Oh, please, I'm like, car. You have to? 2 things multiplied, people. 2 things multiplied. What rule are we going to use? F and G. There is no rule that's called F and G. What's the rule called? Starts with P, rhymes with product. Product. Which indirectly is F times G, but it is not called F and G. So, why is this found in the chain rule lesson? Because to get F prime, I have to do chain rule. To get G prime, I have to do chain rule. But is my main goal here chain rule? No, my main goal is product rule, but I have to use chain rule to get the derivatives. Okay, so F prime is 5. That's just terrible memories. Is 5 2x plus 1 to the 4 times what? 2. Now, you could just leave it like that, but then you're leaving more work to do in a product rule, which sounds terrible. So I'll always simplify my f primes and g primes before I put them in. So I can make that 5 and 2 join because they're both just numbers. So I would get 10 2x plus 1 to the 4. Now, paying attention to me, every single one of you, if your f prime is a chain rule, you will always be able to take a GCF of it out. Why? Because my f is 2x plus 1 to the 5, so there's 5 of them. My f prime, which will be in the other term, will be 2x plus 1 to the 4. So I'll have 4 of them. So in one term I'll have 5, in the other term I'll have 4, and I'll be able to take 4 out. So whenever your f prime or your g prime is chain rule to get there, you will be able to GCF something out. All right. G prime is going to be 4, rewrite this lovely trinomial, to the 3, and then the derivative of that is 3x squared minus 1. Now the 4 won't join the 3x squared minus 1, so you can just leave it like that. In a textbook they would write it as 4, 3x squared minus 1, and the other, but it's commutative property, so like I can move them all around, and they're the same thing. Like 4 times 2 times 8, 8 times 2 times 4, all the same, right? Okay, now we do product rule. So y prime equals g times f prime plus f times g prime, right? So g is x cubed minus x plus 1 to the 4 times f prime is a 5. I'm going to put it in its own brackets because it's all multiplied. That's not 5, it's 10. Come on, Lepp, grab a mitt, get in the game. Okay, 10, 2x plus 1 to the 4 plus f, which is 2x plus 1 to the 5, g prime, which is 4, x cubed minus x plus 1 cubed, 3x squared minus 1. Whenever I do product rule, my end result is 2 terms with some stuff multiplied. Yes? Term 1, term 2, plus sign. Stuff multiplied. So I say to myself, what can I take out of these? F prime was a chain rule. G prime was a chain rule. I'm going to be able to take 2 things for sure out. So if I look here, I have x cubed minus x minus 1 to the 4. So I have an x cubed minus x plus 1, x cubed minus x plus 1, x cubed minus x plus 1, x cubed minus x plus 1. I have 4 of them. Here I have x cubed minus x plus 1, x cubed minus x plus 1, x cubed minus x plus 1 because I have 3 of them. How many can I take out of both? 3. So in the front, I'm going to write x cubed minus x plus 1 to the 3. We agree? Then I look at the 2x plus 1. Bless you. The first term has 2x plus 1 to the 4, so I have 4 2x plus 1s. The second term has 2x plus 1 to the 5. Weird. There's one more than the, of course there's one more. We do chain rule, which drops it down by 1 exponent, right? So one will always have one more than the other one. So this is 2x plus 1 to the 4. This one's 2x plus 1 to the 5. There's 4 of them, 5 of them. How many can I take out of both? 4. You can't take 5 out of 4. That doesn't make any sense. You always take out the smaller one, right? So I take out 2x plus 1 to the 4. Then I have this 3x squared minus 1 just sitting here all willy-nilly. Does it have a friend of itself on the other one? No, it's going to sit there willy-nilly. Nothing's happening to it. And the coefficients I have sitting in here are 10 and 4. Can I take anything out of those? 10 and 4. Anything common to 10 and 4? Remember, GCFs are division. A 2. Okay, then I write what's left over. I can take, there's a 10 in one, there's a 4 in the other, I can take a 2 out of both of them. The 10 will be left with a 5, and the 4 will be left with a 2, because when you GCF, it's division, right? Okay, so let's say what's left in this term. So I took out an x cubed minus x plus 1 to the 3. There happens to be 4 of them, so there's one of those left. Do I need to write it to a 1? No, that's me for effect. Okay. I take a 2 out of 10. What am I left with? 5. And then I take a 2x plus 1 to the 4 out of 2x plus 1 to the 4. They gone. right? No more left in that term. So I just did this first term and GCF these things out. Does that make sense? So I took 3 of these out, I was left with 1. I took a 2 out of 10, I was left with 5. I took both of, like, this whole thing out, so that's gone. Now I have this plus sign here. I'm going to have that plus sign sit right here. It's the same spot. Now I'm going to look at this term and say, what can I take out of u? So I start working my way across, right? I have an x cubed minus x plus 1 to the 3, and I take it out of x cubed minus x plus 1 to the 3. It's gone. Yes? Then I have 2x plus 1 to the 4 out of 2x plus 1 to the 5. What am I left with? 2x plus 1, technically to the 1. Do I have to write the 1? No, I'm doing that for effect. Then I have to take a 2 out. 2 out of 4 leaves me with a what? A 2. And what have I not taken out of this term at all? 3x squared minus 1. We agree? All right. I just have polynomials left in those brackets. What am I going to do? Distribute, collect like terms. So I'm going to get y prime equals this 2x plus 1 to the 4 times 2. I'll usually write the 2 first, but I'm going to just leave it here. And then I'm going to distribute. Boom, boom, boom. So I'm going to get, in this big square bracket, 5x cubed minus 5x plus 5. And then here I'm going to put the 2 in first and then FOIL. So I'm going to say that I have 4x plus 2 in these brackets. And I'm going to FOIL it with this. So I get 4x times 3x squared, which is 12x cubed. 4x times negative 1 is negative 4x. 2 times 3x squared is 6x squared. 2 times negative 1 is negative 2. Do you guys now see that every single outcome in grade 10 is setting you up for calculus? You did a whole unit on polynomials. That was all this distributing that we're distributing. I can't speak. All this distributing that we do inside the brackets, that was polynomial lesson 101 in grade 10. Exponent laws in grade 10. We need all the time, right? We use everything from grade 10. Reducing radicals, changing radicals to exponential exponents, rational exponents to radicals. We use tons of grade 10. So now we have y prime equals, I'm going to put the 2 first because they usually do. If you leave the 2 back there, you are not wrong. X cubed minus x plus 1 cubed. 2x plus 1 to the 4. And then we're left with 5x cubed plus 12x cubed is 17x cubed plus 6x squared minus 5x minus 4x minus 9x plus 5 minus 2 is plus 6. I'm going to get you to try E. The catch is, don't worry about taking out any GCFs yet. I just want you to find out what F prime is, G prime is, and fill in the product rule. So G F prime minus, plus F G prime, and stop. We will do the GCFs together. Okay? So F or G F prime plus F G prime, and stop. So F is going to have to be 2x plus 1 to the half, right? We have to change it to that rational exponent, which once again, grade 10. We know F equals 2x plus 1 to the half. To get F prime, I'm going to have to do chain rule. We agree? Yeah. So F prime is going to be 1/2 2x plus 1 to the negative 1/2 times 2. Cool thing is, these cancel, and it's just 2x plus 1 to the negative 1/2. G is 3x squared minus 5x to the 4. G prime is 4 bracket 3x squared minus 5x to the 3. And then the derivative of that, which is 6x minus 5. Do we agree? Okay. Caveat. Pencils down, paying attention. Say I give you 2x to the negative a half plus 3x to the half. And I say you have to take a GCF of an x out. Everyone paying attention because I will lose you in the next step when we go back if you don't pay attention right now. You will take out the smallest always, right? Like if we had an x cubed and an x4, we can only take an x cubed out of both because you can't take an x4 out of x cubed, right? So we can always take out the smallest. The smallest of this is obviously the negative one. So you're not writing this, we're just learning, so when we go to the next one, we're not lost. So I take an x to the negative a half out, okay? 2x to the negative a half, take out an x to the negative a half. What am I left with? 2, that one's easy. Now plus 3, this is where things go awry. X to the half, taking out x to the negative a half is division. We agree? What do we do when we divide the same base? Subtract. So we actually could rewrite this as x to the half minus negative a half. What happens when you get minus a minus? Plus. So it's a half plus a half. What's that? 1. So I'm actually left with 3x. Boom. What if I give you this? 4x to the, let me think, 2/3 minus 3x to the negative a third. What can I take out? X to the negative a third. At least, the very least, we should know that. Smallest one, right? So we take out x to the negative a third. Everyone paying attention? You'll be lost in the next step, and don't ask me to repeat myself because I'm not going to. We're going to skip to the second term. We're going to end up with minus 3 because x to the negative third gets pulled out. That one's easy, yes? This one, we have a 4, but what do? So we are taking out a GCF of negative a third. So we get x to the 2/3, the GCFs are division. X to the 2/3 over x to the negative a third. Well, we subtract exponents, so we get x to the 2/3 minus negative a third, which is x to the 3/3, which is 1. Right? You have to remember that. So you take out the smallest one, and because we're doing chain rule here, one will be taken out and the other one will turn to a 1 every single time because they're 1 apart. Because when you do chain rule, what's your first step? Take the number, drop it in front, reduce it by 1. Correct? So even if it's a fraction, even if it's a half, we're reducing it by 1, making it negative a half. So that negative a half will come out, it'll be gone, and then the 1 that's x to the half will turn to a 1 because x to the half minus x to the negative half, for dividing them, becomes 1. Every single time we do chain rule because they're 1 apart. So let's go back here and deal with the fraction one first once we put our quotient rule together. So, our product rule. So we get g, which you should have these written down already, 3x squared minus 5x to the 4, because we do goof. G, f prime, is 2x plus 1 to the negative a half, plus f, which is 2x plus 1 to the half, g prime. 4, 3x squared minus 5x cubed, 6x minus 5. Every time I do product rule, I have 2 terms. Term 1, which is gf prime. Term 2, which is fg prime. We agree? Both my f and my g, when I did the derivative of them, were chain rules. So I'm going to be able to take a GCF out of both. I should be able to pull out, at the very minimum, 2 GCFs. So let's deal with the fraction one first because it's the one that most people struggle with. I have 2x plus 1 to the negative a half. I have 2x plus 1 to the half. So I can take out a 2x plus 1 to the negative a half. I have to take out the smallest one. Okay? Then I look at my next terms. I have, what the heck did I write? So I have a 3x squared, I have a 3x squared minus 5x to the 4, and I have a 3x squared minus 5x to the 3. So how many can I take out? 3. This one has no coefficients. This one has a 4 and some weird 6x minus 5 that I can't take anything out. Yes? Okay, let's see what's left over. So in my first term, I'm taking out these 2 things. So if I take a 2x plus 1 to the negative a half out of 2x plus 1 to the negative a half, she gone, right? Then I take out 3x squared minus 5x from 4 of them, so I'm left with one of them. 3x squared minus 5x, technically to the 1 if I so choose, but I don't really need to write that one. I'm putting that as a proof point. Now I took the GCFs out of this term. Now I have a plus sign, so I put a plus sign. Now I need to take the GCFs out of this term. So I have 2x plus 1 to the half, and I take out a 2x plus 1 to the negative a half. That's division. I'm going to show it over here. So I have a 2x plus 1 to the half, and I'm dividing it by 2x plus 1 to the negative a half. What do I do with these exponents? Subtract. So what's a half minus a half? 1. Crazy. Turns to 1. So I'm left with 2x plus 1 to the 1. I'm left with a 4, because I didn't touch that. Here I have a 3x squared minus 5x to the 3, and a 3x squared minus 5x to the 3 I took out, so that's gone. And I'm left with 6x minus 5. Now I have polynomials sitting in that bracket. What do I have to do when I have polynomials sitting in that bracket? Distribute, collect like terms. So, what also happens to this negative half thing? Where does it go? To the denominator and becomes positive a half, right? So I get 2x plus 1 to the half, or I could just write that as the square root of 2x plus 1. Which one's better? The one they want. That's it. The one that matches the multiple choice answer. If it isn't multiple choice, 2x plus 1 to the half is perfectly fine. And then we're left with 3x squared minus 5x to the 3 in the numerator. And then in the brackets, we're left with 3x squared minus 5x plus, and then I would distribute this. Oh, I had the eraser on. So I'm going to distribute these through. So I'm going to write this as 8x plus 4, which is what you've been taught grade 10. And now that's gone, and I have to multiply by 6x minus 5. I would do this in 2 steps, but I have no room, so I'm doing bad math and writing on top of each other. So I have 8x times 6x, which is 48x squared. 8x times negative 5, which is negative 40x. 4 times 6x, which is 24x. 4 times negative 5, which is negative 20. And then I have to collect like terms, so I get 3x squared minus 5x cubed. And then 51. Forgot to start adding. 51 x squared. And then I have negative 5 minus 40 plus 21 is negative 45 plus 24. Negative 45 plus 24 is negative 21. That's the answer that I was saying. And then minus 20. Okay. We're taking a little break ski for right now because we're going to work on some of the homework questions. All of these homework questions, just so you know, are going to be due. Not tomorrow. We're going to work on this part tomorrow, and you work on some of them tomorrow again. Okay? But I'll circle the ones that you can work on today or write them down, but the whole homework is going to be due for Friday. Okay? We're going to work on the other half tomorrow. These are the ones of the homework on this page that you can do tonight. Finish half the homework. And then tomorrow we're going to finish up the rest of this lesson, and you'll be assigned the rest. Okay, so work on these ones right now. You have a little over half an hour. You should be able to finish them.